Welcome to the fourth episode of the webinar focusing on Bin Picking Studio. After this last episode, you should be able to configure a simple bin picking application. Last time we covered the following topics: tool point definition, gripping points, and configuring the grasping method. You learned about invariance and how it could be used as an advantage in robot handling applications. You also covered working environments. We explained all three types: environment, bin object, and collision object. Today we will conclude all the configuration steps by checking the setup in the visualization. We will discuss joint limits and explain network configuration. Finally, after the calibration process, we will deploy the entire solution. The visualization page combines all the loaded CAD models into one complete environment. The model of the robot, according to the selection, is positioned at the origin of the working environment type, environment. It is positioned in the default position according to the manufacturer's specification. The model of the tool is mounted with its origin to the end effector of the robot. The working environment type bin is displayed in the blue color, and the type collision object is colored red and transparent. This page also displays warnings if any of the mandatory configuration steps are missing or incomplete. The warning list is visible at the top of the page. Please click on the link displayed in the warning panel. It will route you to the configuration page where the particular action is required. Please ensure that the list of the warnings is cleared. Unless action is taken on each item in the list, deployment will not be enabled. The visualization page also provides an opportunity to jog the manipulator. The ranges of the joints are based on the technical specification from the manufacturer. These can be further reduced in the joint limit section. This is the time for the validation of the reach of the robot, validation of the gripper design, and visual review of the collision objects. The user should move the robot to the edges of the bin to review if there is a valid kinematic state for future grasp. Along with visualization, there is the question of setting joint limits. Again, the default setting comes from the technical specification provided by the manufacturer. Further restriction is possible. One reason for restriction could be to protect cabling if applicable. We strongly recommend limiting joint 1 to the working volume required to reach a bin. This action will secure quicker path planning and more reasonable robot movements. In addition to the benefits of higher security, you will also get the positive element of faster planning. The reason is we initially try to calculate a trajectory in the joint ranges, and only after that do we test for collisions. After implementing joint limits, please repeat virtual jogging following any adjustment of the joint limits. Let's now remind ourselves of the topology of the entire system. The vision controller is connected to the robotic controller as well as the scanner using an Ethernet cable. This basically means that we need to respect all the specifics of the TCP/IP protocol. Please refer to the diagram in one of the earlier sessions. You will find the vision controller with a color code of NIC adapters. You can also refer to the labels on the back side of the vision controller. On this slide, we display the dialog for setting an IP address for the robot interface. This value will represent the IP address of the network interface, NIC, on the vision controller. Please ensure that the IP address is in the same subnet as the one on the robot. Another configuration to be set is the scanner interface. In a similar manner, please connect to the relevant NIC according to the label or color code. This is the dialog for setting the IP address of the network interface on the Vision controller. The option is to either set a static IP, or the alternative is to use the DHCP service. To correctly configure the NIC in the Foxy scanner, please refer to Section 3, Setting Proper Scanning Parameters, Setting a Static IP. There are two socket communication channels between the Vision controller and the robotic controller. One has already been mentioned, where the Vision controller accepts the requests from the robotic controller. Another one is configured on this page. There is a special routine on the robotic controller which broadcasts a position, such as the joint states of the robotic manipulator, a couple of times per second. This service is called the state server. Please rewrite the IP address from the pendant. Also ensure that you are using the correct TCP/IP port. This routine is required for the calibration procedure as well as for visualization after the deployment. If you are already connected to the robot, you can test the connection by clicking the button. By receiving a confirmation of a successful test, we can consider the network setup as complete for now. One of the biggest chapters of our bin picking studio tutorials would be the process of calibration. However, this does not include the calibration of the Foxy scanner. This device is calibrated within the manufacturing process and does not require any recalibration during its lifetime. Also, we do not include here any hand-eye calibration, by which we mean the Foxy scanner is mounted on the robotic arm. We specifically support in this version the calibration of the Foxy scanner to the coordinate system of the robot. The Foxy scanner needs to be mounted in a fixed position, free of any movements or vibrations. The goal is to align the scanner space to the robot space. Scanner space is the default setting in the scanner. It refers to the origin of the Cartesian coordinate system of the acquired point cloud. By default, it is in the virtual center of the optical sensor of the scanning device. This point is known to the Vision system. However, our robot does not know where it is located relative to its own coordinate system. The purpose of the calibration is to calculate a transformation matrix which will recalculate the final point cloud and transform it to the coordinate system known by the robot. It is usually located in the base link of the robot. After completing all the required steps, the matrix will be stored in the scanner and the default setting will change to robot space. Now the scanner will provide a point cloud in the space of the robot. Please acknowledge the disclaimer to start the calibration procedure. The first task on this page is to set the radius of the calibration object. For the purpose of calibration, we are using a calibration object which is a ball. Good results have been achieved using a table tennis ball. The radius of the table tennis ball is usually from 19.8 to 20 millimeters. For the XL size of the Foxy scanner, mounted at a height of 3 meters, a table tennis ball might not perform sufficiently well because it is simply too small. Here we have had good experience with a snooker ball. What makes these two good candidates for this process is their solid manufacturing precision driven by international standards and wide availability. The application will check the availability of the scanner according to the selection of the Vision System section. The page also contains information about any previous calibration. Connect to the scanner by clicking the button. Similar to the previous page, at this stage we are connecting to the robot according to the selection in the Robot section. Please click the Connect Robot button to initialize the calibration process and start adding calibration points. So, we use a ball for the calibration procedure. There are a couple of rules we need to follow during this process. Again, we recommend using a ping pong ball for smaller sizes of the Foxy scanner. Another option is to use a snooker ball or any other ball precisely manufactured with a smooth surface. The calibration object needs to be mounted on the tool behind the 6th joint. You get the idea by inspecting the 2 pictures on this slide. Please position the ball in the scanning area and add the calibration point by hitting Add New Calibration Point button. You will see the texture frame on the right. There is an inbuilt algorithm which is looking for a ball in the scanning area of the given radius. Please review the texture frame by looking for a red disc. Decide if the visualization of the disc represents the position of the calibration object. In the case of success, you can proceed to the next calibration point. Jog the robot to capture various distinct positions. We recommend moving the joints as opposed to making a linear movement. At every position, jog each joint. The robot position and rotation are downloaded from the robot controller at the moment of adding the calibration point. The theoretical minimum number of calibration points is 4. However, despite the fact that the calibration reprojection error with 4 points will be very low, the result will be inappropriate. We recommend 10 calibration points. These points should be acquired in the volume where the bin will be positioned, so good practice is to actually remove the input container for the period of calibration, acquire the required number of points, and move the bin back into the robotic cell. While adding calibration points, please watch out for notifications in the top right corner. The system will inform you about acceptance of the calibration point. However, the point can also be rejected. The reason to reject the calibration point is usually the fact that the new point is very close or similar to the one which was added before. In the case of rejection, we recommend adjusting the position of the robotic manipulator firmly by jogging every joint. At the very last stage of the calibration procedure, we recommend reviewing the accuracy of every point compared to the overall calibration accuracy. You may consider removing outliers. However, a higher reprojection error for a particular point will not necessarily mean error. Also, this point may contribute a reasonable transformation at the end of the day. Finally, transfer the computed calibration matrix to the scanner by clicking Finish and Save Calibration. The calibration matrix will be stored in Bin Picking Studio in the section of the Vision system as well as in the Foxy scanner. It can also be reviewed in the Foxy control in the section Robot Space. To facilitate future recalibrations, you may consider storing the calibration as a sequence of points in the robotic program. This might be necessary if a slight adjustment to the robot position or scanner happens. At this point, we have finished all the mandatory steps of the bin picking application configuration. We are ready to deploy. The menu for deployment is accessed by clicking the deployment link on the top right. You will be able to choose a solution from the drop-down list. Please note that only solutions which are marked with Ready for Deployment flags are listed here. If your solution is not marked as ready for deployment, please open the solution and navigate to the visualization page. Here at the top, all the incomplete steps are listed, and you can navigate to that particular incomplete step by clicking on the link in the error section. When deploying your solution for the first time, we recommend having the robot in the hand mode. Also, this is a good moment to validate the alignment of the bin. Please turn on the deployment of the desired solution in Bin Picking Studio. Do not start the bin picking program on the robot while your state server is running. Manually position the robot so that the end of the tool touches one corner of the bin. In the 3D visualizer on the deployment page, verify that the robot model position in relation to the bin corresponds with real-world placement. If you spot a significant inconsistency, please move the CAD model of the bin object. Repeat this procedure for all 4 corners of the bin. Alternatively, this process could be combined by reviewing the point cloud in the visualizer. The idea is to review how the point cloud from the scanner overlays the CAD model of the bin. Now for the final stage of deployment. Please keep an eye on the statuses of robot, bin picking process and scanner. These traffic lights give you the first idea of the system condition at any time. For more detailed inspection, there is a window with status messages at the very bottom. Thank you very much for getting as far as the very last slide of the series of seminars focusing on Bin Picking Studio. However, this is far from the end. We have just covered the basic features customers may need for implementing a bin picking application. At this very moment, the team is working hard to add new features which will improve customer experience and extend system capabilities. Let's name a few, like system run monitoring, gripping points to tool points proportion analyses, localization and Foxy integration, bin picking simulation mode, teaching gripping point, and many others. And the path does not end here. We are dedicated to go beyond the bin picking applications and take this system to a whole new level and revolutionize the robotics. So please be our guests on our journey. Please leave your feedback at support@photoneo.com. See you at the webinar dedicated to the new features announced in the version 1.2.0. Thank you and goodbye.